let's continue the lecture with this slide. Okay, so this slide is trying to explain about the internal forces in the arch. Okay, so what you can see here, this is a cut section of the arch, okay, from this complete diagram of arch structure. Okay, so what you can see here is they have three internal forces, which is radial shear force, okay, so the axial force and the internal moment. Okay, so these internal forces is actually similar to the beam, okay, but then the difference is only on the orientation of the shear force and the axial force. Well, you can see here the axial force and the radial shear force is oriented in different angle or position according to the position along the arch. Okay, so and one more thing that you need to highlight here is the axial force must be perpendicular to the radial shear force. Okay, so and this radial shear force must be draw parallel to the cross section of the member. Okay, so and the axial force will be perpendicular with respect to this radial shear force. Okay, so let's continue with the another slide. Okay, so so this is a procedure of analysis. Okay, so basically the procedure of analysis is quite similar to the beam analysis, but then they have one another additional step, where at the step number 2 that you can see here. Okay, so if you compare this analysis with the beam analysis, okay, actually the step is quite similar, because if you look in the beam analysis, we need to find out the support reaction, okay, and you need to solve for the internal forces for the beam, okay, so and you need to draw the bending moment and show diagram for the beam. Okay, so the step is basically similar to the arch, okay, but then they have additional part where at the second, where you need to find out the rise y and the angle theta. So I can say that the method used for arch analysis is a method of section that we have applied in the beam. Okay, so the y and the angle here can be obtained by using specific equation that we will go through in detail in the next slide. Okay, so and this value of angle and y will be changed accordingly to the position of arch, okay, the position of the cut section on the arch. Okay, so let's read on the equation of y and the angle. Okay, so actually the equation of y and angles is obtained by using the equation of a parabolic equation, because the arch shape is a parabolic shape, so we can use the parabolic equation in order to get the height y and the angles of arch at different position along the arch. Okay, so this is a parabolic equation. Okay, so and you have seen this in the mathematics. Okay, and the equation is y equal to kx multiplied with l minus x. Okay, so okay, you can see that here we have a term of k. Okay, so which is a constant here, and this value of k can be obtained by considering the position of x, or specifically if you look in the diagram at the point C, where we have a coordinate of L over 2h. Okay, so by substituting the coordinate at point C, you can solve for the value of k here, means the equation of k here, which is k equal to 4h over L squared. Okay, you can try yourself to prove this, okay, by substituting the coordinate C into the parabolic equation. Okay, so and you can substitute this k equation, okay, into the parabolic equation, and you will get the equation of y. Okay, so this is rise y. Okay, so this y will be difference, or it will be changed according to the position of x okay, based on this diagram. Okay, so consider this point A as a starting point, 0 point. Okay, so this y will be changed according to this x. Okay, so L is a length of arch, or the span support to support of an arch. Okay, so and the slope or the theta can be obtained by differentiate this equation. Okay, so if you differentiate this equation of y, you will get the slope equation. Okay, and the slope must be in an angle. Okay, so but here if you substitute the value of L, H and X inside this equation, you will get in terms of radian, but in calculation you will use the angle, so you need to convert the radian into angle. Okay, so this is a scope of analysis. Okay, so you are going to analyze the arch based on the different load condition and also based on the different support condition. Okay, so we will analyze the internal forces in the arch based on the vertical point load, based on the lateral point load, and the UDL. Okay, sometimes it can be combination of all these three loads. Okay, so and the support conditions, they have two situations of arch shape. Okay, so the different situation will be in terms of a same level of support or different level of support. Okay, so okay, this is the conditions of in terms of load and support, where we will see in the example later on. So we will discuss some example based on this different condition of load and support. Okay, so we will continue the lecture on the example. Okay, so we discuss in detail on a few examples how to analyze the arch and how to determine the internal forces, okay, and to draw the bending, shear and axial force for the arch. Okay, so stay tuned with me.